Well, this video is for Math 70, and this is for the assignment on solving proportions. So proportions are like fractions. So let's talk a little bit about fractions. Let's see here. Let's say we have, well, let's use 2/3 and 3/5. So this is something I remember doing in elementary school when we learned about fractions. Is we would get two fractions, they would ask us which one's bigger, and we learned that we can multiply. 5 times 2 is 10, 3 times 3 is 9, the 10's bigger than the 9, and so 2/3 is bigger than 3/5. It's a neat little trick. Well, let's talk about what's going on, because all of these tricks in mathematics have reasons why they work, and I find those reasons a lot more interesting than the tricks themselves. Okay, a shortcut is helpful sometimes, and don't get me wrong, I like a good shortcut, but I find the reasons why those shortcuts work to be very, very interesting. And this one is pretty interesting. I wouldn't put it up there with some of the other ones I've looked into. So what's happening here is that we're not really multiplying 5 times 2. We're taking the fraction 2/3 and we're multiplying it by 5/5. That makes it 10, or equivalent to 10/15. And we're not just multiplying this 3 times 3 to get 9. We're taking the fraction itself and multiplying it by 3/3, and that gives us 9/15. So now we're comparing 10/15 to 9/15. Obviously the 10/15 is bigger. So that's what's behind this little trick, that shortcut. Okay? So, same thing goes, let's just take a very simple example here. Let's say we've got x/7 equals 9/4. Okay? So one way to go about doing that is that if these two fractions are equal, then when we do this cross multiplying, 4 times x, 7 times 9, those two things should be equal as well, for the same reason. Okay, so there's that cross multiplying step. I'll do the long version of that over here. So the long version of that is that, let's see, we're going to, well, we'll multiply by 7 on both sides. And that'll give us x equals 63/4. And then we can multiply on both sides by 4. And there's our 4x equals 63. So that's the long version of this cross-multiplying process of solution. Okay? So there's the justification for the reason why we can, if we've got something where a fraction equals a fraction, we can cross-multiply, and then those two things should be equal to each other as well, is that here's the long version of that. Okay, so there's a justification for the process that we're going to be using to solve these equations. Let's see here. Let's start with problem 4. Here we've got 81/64 equals 27n/40. Okay, well, we need to cross multiply, so I'm going to get the calculator out here. This looks like it should be 324, but with a 0 on there, so 3,240. And then over here, 27 times 64, 1,728n. And then we got to divide on both sides by this 1,728. And so what are we going to get here? 3,240 divided by 1,728, 1.875. If you like fractions, I think that's going to be 1 7/8 or 15/8. Okay, but there's nothing wrong with 1.875. Okay, problem 6. There's a little bit more going on here. Y/y minus 3 equals 7/2. So then we'll go ahead and cross multiply, and we'll say 2y equals 7 times y minus 3. You can do that multiplying in one step too if you want, but I'm just going to take an extra step here to get to that 7y minus 21, 2y over here. Okay, so let's subtract 7y on both sides, right? Because this is a positive 7y. If we want to move it to the other side, we have to do the opposite, negative 7y. Over here we'll get minus 5y. Don't lose this negative sign that's attached to the 21. Negative 21. Now, divide on both sides by negative 5, and y is going to be equal to, this is going to be 4.25. 4.2. 4 and 1/5. Okay. So, now that we know that method of solution across multiplying. Once we do that, you can see, now we're just using those skills that we learned in, or covered in those previous two assignments for solving linear equations. Okay. Let's see here. Let's look at problem 10. Here we've got 5 over y plus 2 equals 4 over y. All right, same thing. We're going to cross multiply. Over here, we'll get 5y. Over here, 4 times y plus 2. So that'll be 4y plus 8. Subtract 4y on both sides. Y equals 8. Pretty straightforward. And you can plug it in and see, does that work? Yeah, 4 over 8 is a half. 8 plus 2 is 10. 5 over 10, also a half. Okay, let's see here. What else? Let's see. Let's skip over to problem 16. We've got 2n minus 1 over 21 equals 3n minus 7 over 15. Okay, so we'll start out same way, multiplying 15 times 2n minus 1 equals 21 times 3n minus 7. So let's see, this will be 30n minus 15. Over here looks like 63n minus, let's see, 147, looks like. Okay, so let's see, I'll move the 30 over here. And then move the 147 over here. So subtract 30 on both sides. And that'll give us negative 15 equals 33n minus 147. And then add that 147 to both sides. So 33n. And then over here, what is that going to be? 132 it looks like. 132. Let's see here. Is that 33 times 4? I believe it is. 132 divided by 33 equals 4. There we go. So that cancels out and equals 4. All right. See, what else have we got here? That was 16. Let's look at 18. 7 over 8 equals 6a minus 2 over 5a plus 7. Okay, so let's cross multiply. 7 times 5a plus 7 equals 8 times 6a minus 2. Okay, so next we're going to go and distribute into the parentheses. So let's see, this will be 35a plus 49 equals 48a minus 16. So I'll do the same thing I did here. Let's move the 35 over here, add the 16 over here. And you can do that in one step if you want to. Just in terms of teaching. I typically do this in 2 steps so that people don't get confused. But if you're comfortable doing it all at once, then by all means go ahead and do that. Let's see. 48 minus 35, that should leave us with 13a. Add the 16. 13a is going to equal, looks like 65. And if we divide on both sides by 13, a will turn out to be 5. That doesn't look very much like a 5. There we go. Okay, let's see what else we've got here. Let's look at problem 20. So 2x minus 9 over 7 equals 3 minus x over 4. All right, so let's cross multiply. That'll give us 4 times 2x minus 9 equals 7 times 3 minus x. So 8x minus 36 equals 21 minus 7x. Okay, I'm going to move the 7x over here. So that'll be 15x minus 36 equals 21. And then we'll add the 36. Let's see, 15x equals 57. Well, that doesn't look like it's going to turn out to be a nice whole number. Let's see what we come out of this with. 57 over 15. That's going to be, oh, is that 3.75? Let me see here. 57 over 15. Oh, 3.8. Oh, I keep doing that. Thinking in terms of fourths instead of fifths. Let's see here. 12 over 15. So what's happening here is 3 times 15 is 45. And this is 12 more than that. So it's 3 and 12/15. So I think I reduced that fraction wrong. Let's see, those are both divisible by 3. So that's 3 and 4/5. I thought it was 3 and 3/4 for a minute there. Okay. Well, let's look at one more here. Let's see what we've got. Problem 22. 4y plus 12 over 8 equals y plus 3 over 2. All right, so 2 times 4y plus 12 equals 8 times y plus 3. All right, so this will be 8y plus 24 equals 8y plus 24. Now, we haven't talked about this very much, really at all, and you won't see it on your quizzes and tests either. But what happens in a situation like this is that, notice, if I subtract 8y on both sides, this cancels out and this cancels out, and I end up with 24 equals 24. And I can subtract 24 on both sides and get 0 equals 0 as well. What that's saying is that these two things are actually the same thing, is that this is no more than an equation that says x equals x, okay? And the solution for this problem is any number. 10 equals 10, 20 equals 20, 100 equals 100, okay? So that's why this solution is all real numbers, okay? Now there's another thing that can happen where, let's say we have, 4x minus 7 equals 2 times 2x, let's say 2x minus 5 plus 3. Okay, so I just made this one up just to demonstrate something for you. And like I said, this is not going to be on the quiz, not going to be on your test. So, this stays the way it is. Over here we get 4x minus 10 plus 3. Oh, darn, I made a bad example here. So let's put a 1 over here, okay? All right, so Now, this is 4x minus 7 equals 4x minus 9. And if I subtract those 4x's away, I get negative 7 equals negative 9. That's not true. So what this is saying is that no matter what value of x you put in here, is not going to make this true, okay? In fact, this statement will never be true no matter what the value of x is. Whatever value of x you put in here, these two sides are never going to be equal to each other. So that's a no solution problem. And this one, this is no matter what value of x you put in there, they're always going to be the same, okay? So those are the two types of problems, all real numbers versus no solutions. And that's what happens when you get the same number of x's on either side, okay? And you go to try to, cancel out one side and you end up canceling out the other side as well. When that happens, you're either going to end up with an all real number situation, which actually says that these things on either side are the same thing, or you're going to end up with a no solution, which is basically saying that these two sides will never be equal to each other. I wouldn't worry too much about it. It's kind of an interesting thing. However, like I said, you won't see it on your quizzes and tests. And in fact, I'm just looking at the answer key for the odd problems. It doesn't show up in the odd problems at all. Okay, so that's it for this assignment. Once we get done with this, we'll move on and talk a little bit about inequalities. And as always, if you have any questions on this, please let me know. Thanks.